Hello, everyone. Good afternoon. So we are in the second day, last session. I believe most of us are tired, but thanks a lot for showing interest in our session. Today we are going to talk about a new feature we're gonna deliver, and this project is a big and large-scale project, I can say. So this is the next big thing coming in with NSO. And it all started with a research project, turned into an engineering project. So I'd like to also thank our research team for enabling this, Rieng and Victoria Ferdersh. I am Erdem Aksu, my colleague Claes Nasten. So I'm gonna hand over to Claes to present this feature. It's on you, Claes.
So let's see how this works. Yes. Yeah, NSO might be consuming a lot of memory for you, and so it does for us. So we have been thinking about what we can do about it. So first off, I'm going to talk a bit about what's actually consuming memory in an NSO installation. On the top of the list, we have CDB. And typically there we have the device data being the most major player, and then service data. In addition, if you have a lot of NEDs, large NEDs, multiple versions of NEDs, the schema data can become quite substantial. In addition, you have your workload, the transactions, the service invocations, and that both gets reflected in the NSO process and your Java and Python VMs. If you would look on that as a pie chart, you can see almost 90% of the memory can be CDB data. It can be even more, of course, depending on your configuration. This is from an actual customer installation. Most of it is, the rest of it is quite small, not worth mentioning in the large scheme of things. Yep. So currently, CDB we have, it's an in-memory tree database, and it has a few good properties, like it has very low read overhead because everything is in memory. It's great. It's backed by a journal file only, which is good in the sense that it's very low write overhead. You just append to a file over and over and over again. Super fast. However, as you might know, it requires compaction, which is less fun. And also, it requires all data to be loaded at startup. And why does it do that? Yes, because when you start up, you have a transaction, it fills your operations in there. You added this node, you deleted that node, etc. And then the next transaction comes, maybe updates the node you previously created, and so on and so forth. If I would load half of that file, I wouldn't have the complete picture. Maybe something that would be there then might have been deleted afterwards, or vice versa. So you need to read the full file to build the full memory tree. And it's just a transaction log, so it's not structured in any way, shape, or form. You can't say, I want to load this part of the tree, because it's just modifications anywhere in the tree per transaction. So what did we do about this? How did we make this any better than it is today? Yes, we still have the in-memory tree as before. It's proven, it works. We still want to keep the low read overhead. So now we have an in-memory tree. However, it no longer reads the full data when it starts up. It loads data on demand. So let's say you want to access some part of the CDB. It'll figure out, oh, this is not here. It'll load it instantly, return it back, and then it will load keep filling up relevant parts of the tree so that subsequent loads or reads gets faster. In addition, we don't want it to continuously grow. We want it, after a while, to be able to remove stuff from the tree. So we keep track of that too. In addition, it's now backed up by disk storage, not a single journal file. Currently, we're using RocksDB at the low level to store the data for us and to allow it to read it back. On a very high level, it looks something like this. We have CDB, we have the in-memory tree where we read data. We can also instruct the in-memory tree to drop data because we need to free up resources. In addition, the in-memory tree is now aware of the disk storage below it, so when it doesn't find something, it'll request it, load it back in. Previously, CDB would have been writing to the write headlog or the journal file. It does not do that anymore. It writes to the disk storage directly. So we have the data offloading too. To make that as performant as possible and to make it possible to add that in without causing too much overhead, too much memory consumption, we only support offloading on select parts of the tree. If we would double back to the pie chart I showed before, it's basically device data and service data. That's the thing that consume memory. So we keep track of those. Everything under devices device config is tracked, so we know when it was accessed. Same goes for entries under service points. So if you add a service, it'll automatically be a candidate for memory offloading. The offloading currently supports two different types of offloading. Either you hit a memory threshold, so NSO or the CDB data is consuming too much space. We start trying to drop the oldest data from the tree. So whenever you read something, it will be moved to the front, and yeah, it's recent data, we won't drop it, but if it's not touched, it will go back, and that's the candidates for offloading. We also have age-based offloading, so if you just want your system to go back into a low memory consumption state if it's idle, you can use that too. Worth mentioning, currently the offloading is not done like you hit this threshold, it'll hit instantaneously. It's done periodically. This is also to reduce the impact of the offloading. So, what did this give us? Was there any gains to be seen? You need to keep in mind I'm a Swede, so I'm quite conservative. There's no like wows as you would have from potential other nationalities. So anyway, if you look at this example, we have a memory consumption at the startup. With CDB, it's higher because when you started it up, it loaded all the data into memory, right? With the new disk storage, it doesn't, so it's lower when it starts. However, when you start creating services, they basically increase as much, both of them. However, when you hit the offloading threshold, it goes above, mind you, because it's not instant. It happens periodically. However, it'll start removing data as it goes, and it'll hover around that line, the threshold line, depending on the intensity of the loader system. And that's the current default behavior. This is not released yet, so it might change, but we will allocate 50% of system memory for CDB. Another nice thing that happened is startup time reductions. However, we need to keep in mind that CDB data loading is not the only thing that takes time when we start. Schema loading is another major player. So if you have a small database, I'm not presenting actual numbers, just a small database and a small schema, you won't notice any difference because it's fast enough. However, if you have a large database, 20 gigs, 40 gigs, whatever, and a reasonable size schema, you will see major gains in startup times because we don't load all the data in when we start up. Again, you have a small database, you have a large schema. The schema loading will still be the one that takes the most time, so not so interesting. Again, last example, if you have a very large database and a large schema, it won't be as dramatic, but you'll still see improvements. I mean, we have seen from 10 minutes down to a minute, to from 3 minutes down to 30 seconds. I mean, it all depends. But the improvements can be major. Unfortunately, there's no such thing as a free lunch. We do keep track of more things, and that comes with an added overhead. So that typically varies around 2 to 10%, depending on. Mind you, this is still in development, so we haven't done the final optimizations before the release yet. For our more realistic customer-based scenarios, we've seen around 2% decrease in performance. And that goes down when you have hot data as opposed to when you have cold data that needs to be loaded in. There are some scenarios that it becomes more evident that this costs, and it's typically when you have, like, you want to create a rollback file, and you delete something, and under that thing you deleted, there's a large tree of config data that's cold. Then that needs to be loaded into memory for the rollback file can be created because it needs to contain all the information to recreate that tree. Not yet optimized. We have ideas to improve it. Sync from is another scenario because then we need to compare the full device configuration in CDB with the one on the actual device. Changing the disk storage also got rid of the background compactions. No, got rid of the compactions. You're now doing compactions in the background, so we don't get service interruptions when we reclaim space from the hard drives. And it happens incrementally in the background without you having to do anything. With all this in mind, we now think you should be able to manage a lot more devices on a single NSO node. Because typically, full device configuration is quite large. It will consume a substantial amount of memory in RAM. But your services typically don't touch all of that config. So you have your services, they will update a tiny bit of it. Our tests indicate that too. So even though if all those devices would take hundreds of gigs to have in memory, you probably will only be touching a few of them at a time. Also, you will also be touching only a small portion of them at a time. So instead of having service sizing being limited by RAM, we now think that it'll be limited by transaction load. So if you have a system that doesn't have too high of a pressure when it comes to multiple transactions per second, instead you're doing less frequent updates, that will be like the transaction intensity will be the factor that determines how many nodes you will have to have. To make this even more clear, so if you would paint an ideal use case, you would have devices with a lot of configuration in them in your network. You would have a lot of devices in your network, and you will manage a lot of devices. And your services touch only small portions of those devices. And the devices you touch are typically the same. That would mean, yes, you now need to have a lot of memory to store all that device configuration for all your devices. But you wouldn't require that anymore because you would only have to load in this tiny bit of configuration from the device, or small portion of it at least. And you would always have that in memory because you would never hit the threshold because you're only updating, at least from the frequent devices, you would be updating them and they will be hot. So the overhead would be as small as possible. And while working with this, a few common questions has popped up. First off, is it backwards compatible? It's a yes and a no. I mean, from a functional perspective, you should see no difference apart from NSO using a lot less memory. However, the on-disk storage format is, of course, different. So you can't just grab that new disk file and use it on an old system. Won't work. And that leads to the next question. Does it require migration? Yes, it does. However, it's that simple. You just add the new persistence settings in NSS-conf, start up, and NSO figures out, oh, this stuff on disk is the old format. I need the new format. Let's convert it for you. And it'll be converted. And if you, for whatever reason, figure out, oh, I want to go back, you can just remove that configuration from your configuration file, restart NSO. It figures, oh, this is the wrong format, and it will convert it back to the legacy journal file format. When do we think this will be available? It's currently scheduled for a 6.4 release. So unless something very unforeseen happens, you will have it at the end of the year. One thing worth mentioning is that when you do these migrations, you need to have enough disk space. And from a disk space perspective, it's quite equal. If you have a journal file that's compacted and the new format, it's basically the same. It depends on the structure of your tree, how much it will differ, but it's plus minus 10% currently. Questions? So I found a quote that should encourage you to ask questions, even though there have been few during these days. Any questions? I'm done. I could talk a lot more if you have questions. Or just...
Is this on now? Okay. Yeah, very good. Well, we actually do have some questions. So let's have a look here, if we can get it up. See if it comes. There's the first one.
Yes, I can say.
Let's read the question. Does IOAPS, I guess the type of storage, right, impact starting of NSO more with this feature? In the future?
Yeah, the library we use is RocksDB underneath, and RocksDB is optimized for solid-state drives, flash drives. So that would have an impact, and it performs better on SSD.
However, you would need to load in a lot less data, so in the large scheme of things, it might not. But theoretically, it should.
Yeah, probably we should put into documentation as a suggestion, like recommendation, right?
Yep.
Here's another question. Is there some side effects with devices that need continuous connection to receive notifications, for instance?
I would think that would keep that data hot and never being offloaded.
Yeah, but that's the operational store. Like, I assume you're talking about like netconf notification streams and whatnot. I don't know.
Maybe some extra.
Yeah. So that part of the tree will be kept hot in memory. However, it's a small. It won't load in everything for the device. It will only keep the notifications in memory.
Another one. Will you add something else than RocksDB if I need it? Question.
I mean,
should I be honest?
I don't know how important your need is, but yeah, if we give some details on development, we kept it pretty modular. This goes long history back, actually, right? With the thing I told about research and the improvements we did on backend. Now we are focusing on keeping our backend more modular and easier to work on. Theoretically, I would say anything is possible. And this is the proof of it already. and but there's no plans, of course. I mean, it's probably never gonna happen.
Here's another one. How will this affect NSO LLM queries?
I mean, depending on what the queries will produce for reads, it could, of course, have a negative side effect on performance. If you start reading all over the tree and it's cold, you will see a degradation in performance if that's what you're after. But yeah, that's my best answer. Have any other things to add?
No.
I mean, it's worth mentioning. Like we operate on a few assumptions here. We assume that services manage only parts of the device data. We also assume that some devices are more frequently updated than others. So, in general, and if you have an installation already that has enough RAM, adding this, basically all the data you need after a while will be hot, because it will never be offloaded, because you already have enough space and you won't be reading all of the devices in.
Another one, very good. Let's keep the questions coming. We have a little bit more time before we have to wrap. But let's go through this one. Will you still check the entire DB for corruptions during startup, or only loaded parts? That's the question.
No, no such thing. I mean, for only loaded parts. I suppose this is corruptions on disk is meant here. That would go for all the database, but of course using checksums or whatnot. Of course, we're gonna depend on lower level libraries on this.
Yeah. I mean, just to be a bit, we don't have data checksumming in the current format either. So even if we loaded it in and it was corrupted, we wouldn't notice it. I think RocksDB has checksum corruption, so we could add, like, I want to check my full data store before loading it in. Of course, you won't have the startup performance gains then.
Yeah.
Everything comes with a cost.
Here's maybe the last question of the day and of this session. Is there going to be a new tail flag added to keep specific data hot?
Not planned, but it's a good suggestion. If you really know you need this stuff in, we could make it load during startup and never offload it.
Yeah,
it's good. It's a good suggestion.
Good feedback. I want to jump back about the performance of some data. We are providing some configuration options with this, and depending on the use case, actually you can configure lower thresholds or higher thresholds, or offloading periods frequency, plus, as Claes explained, the maximum age to keep in memory. So with some adjustments and playing around, I think you can find a good optimized setting for your use case in this setup.
Okay, Niklas, do we have time for one more question? Or okay, let's do this one. Is the threshold to move data to disk configurable, and or can we still decide to use all of the available memory, 100% of memory?
That's exactly what I was talking, right?
You can use it all. However, I mean, you can't use 100% of memory, because then NSO won't have any memory. So, and you know, your services or Python VMs and whatnot. But you can configure a threshold really high. Yes.
Okay, more questions coming in. I'm going to take the liberty now and do another one. I think you're going to be quick in wrapping anyway, Niklas. So let's do this one. More performance questions. Would XPath eval have the same performance?
If the data is hot, and if you do it once, it will be hot. And if it's not offloaded, it will be around for the next time you evaluate it. Of course, if you do like a double slash something on the root, of course, you would have to scan the full tree, and that would be bad. So, I mean, it's worth it. This is a good point. And it's in general a performance killer to do these very broad things. It's the same for like in NSO 6.0 when you don't want to have conflicts in your transactions. If you were using them, you would have a lot of stuff in your read set, you would get conflict. So it's bad from that perspective, and it will also be bad here because you're likely not going to have everything in memory.
Yeah, I would reiterate on the configuration. I mean, if you don't want the data offloaded, keep the threshold higher, right? And for such expert evaluation, in the end, it depends on the use case. Try to keep the data hot in the memory. And if not, increase the memory capacity. But you'll go back to the original NSO in the end if you want everything in the memory readily available.
Okay, I think that's a wrap. Claes and Erdem. Thank you so much. Claes.